The diagram shows point A and B on the curve. The tangent to the curve at B crosses the x-axis at C. The point D has coordinate 2, 0. Find the equation of the tangent to the curve at B. Hence, show that the area of the triangle BDC is 4/3. So we have to find the gradient of the tangent. So y equals to 8, 3x plus 2. So dy dx will be equals to the power of -1. Yeah? So it's -8, 3x plus 2 minus 2 times 3. So -24, 3x plus 2 minus 2. At B, the coordinate 2, 1, so the dy dx equals to -24. I can rewrite as fraction 3 times 2 plus 2 square. So this is -24 over 6 plus 2, 8 square. So equals to -3/8. So we can find the equation of the tangent, y equals to mx plus c. And then using the coordinate b, 2, 1, it's 1 equals to -3/8x plus c. So 1 equals to -3/8 times 2 plus c. 1 equals to -3/4 plus c, and c equals to 7/4. So the equation of the tangent will be -3/8x plus 7/4. And then to find the coordinate c, c is the x-intercept, so it's x, 0. So I can put 0 equals to -3/8x plus 7/4. So that means 3/8 x equals to 7/4. So x will be equals to 7/4 times 8/3. So this is 14/3. So x will be 14/3. So the area of the triangle area is half times base times height. So the base will be from 2 until 14/3. The base is half 14/3 minus 2 times the height is 1. This one, yeah? 1. So this is 1/2 times 8/3 times 1 equals to 4/3. Sure, yeah? That's for I. And for II, show that the volume of the solid form when the shaded region is rotated completely about x-axis is equal to 8 pi. So we will find the volume. We can use the formula pi integral from 0 until 2 of y squared dx. So pi integral 0 to of the equation y 3x plus 2 minus 1 square dx. pi. Okay, I make this 0 to 64, 3x plus 2 minus 2, the x. I will move out the 64. So integral 3x plus 2 minus 2 dx from 0 until 2. So this will be minus 3x plus 2, negative 1, and then over 3, 0, 2. So the negative 1 over 3, I move out again. And so negative 64 pi over 3. And this is equals to 3 times 2 plus 2 minus 1 minus 3, 0 plus 2 to the power of negative 1. So negative 64 pi over 3. This will be 1 over 8 minus 1 over 2. So equals to negative 64 over 3 pi. So this is 1 over 2 minus 1 over 8 minus 1 over 2. 1 over 8 minus, so negative 3 over 8. So equals to 8 pi. So this will be proven. The diagram shows part of the graph 18 over x and the normal to the curve P. The normal meets the x-axis at R. The point Q on the x-axis and point S on the curve are such that PQ and SR are parallel to the y-axis. So this is perpendicular, yeah? Find the equation of the normal at P and show that R is the point for half 0. Okay, normal, so we have to find the gradient of the tangent. So the gradient of the tangent is the first derivative of the function y equals to 18 x minus 1. So dy dx will be negative 18 x minus 2. So at the point when x equals to 6, the dy dx will be equals to negative 18, 6 minus 2. So it's negative 18 over 36, so equals to negative half. That means the gradient of the tangent will be negative half, and the gradient of the normal will be 2. So the equation of the normal will be y equals to mx plus c, so 2x plus c. Finding c, we can replace the coordinate p. So 3 equals to 2 times 6 plus c. 3 equals to 12 plus c, so c equals to negative 9. So that means the equation of the normal will be 2x minus 9. And then the coordinate of r, where r is the y-intercept, is x comma 0. So replace is y equals to 0. So 2x minus 9. So x equals to 9. So x equals to 9 over 2 or 4 half. So r will be 4 half comma 0. fraction. And then for II, show that the volume of the solid obtained when the shaded region is rotated to x-axis is 18 pi. So we rotate the x-axis. So the volume will be pi integral of the function square dx. So pi integral from r is 4.5, 9/2, until q is 6. So until 6. So this is 18 times x minus 1 square dx. So this is equals to 18 square will be 324. I can put it out from the integral, so 324 pi. I put it together, 9/2 until 6, x to the power of minus 2. So 324 pi. The integral of x to the power of -2 is negative x minus 1. 6, 9/2. So 324 pi. I put the negative out. So it's 1/6 minus 1/9/2. So equals to negative 1/18, negative 4 pi. So it's equals to 18 pi. Yeah, proven, yeah? Next, the equation of the curve is y equals to 6/5 minus 2x. To calculate the gradient of the curve at the point where x equals to 1. So find the gradient, dy dx. This is 6 times 5 minus 2x minus 1. So will be negative 6, 5 minus 2x minus 2 times negative 2. The gradient, the derivative of 5 minus 2x. So equals to 12 over 5 minus 2x squared. So when x equals to 1, the dy dx will be equals to 12 over 5 minus 2 times 1 square equals to 12 over 9. So equals to 4/3. A point with coordinate xy moves along the curve in such a way that the rate of increase of y. So we meet again with the rate of change. So this will be dy over dt has a constant value of 0.02. So 0.02. Find the rate of increase of x when x equals to 1. So we are looking for dx dt. So using the chain rule, dx dt is dx dy times dy dt. So dx dy when x equals to 1 is equals to 1 over dy dx times the dy dt. So it's 0.02. So this equals to 1 over 4/3. We can take value from here because this is the value when x equals to 1 times 0.02. So it's 3/4 times 0.02. So it's 3/200 unit per second. That's the second one. And the third one, the region between the curve x-axis and the lines x0 and 1 is rotated through 360 over the x-axis, so that the volume obtained is 12 over 5 pi. The volume integral pi from 0 until 1 of y squared dx, pi integral 0, 1 y squared. So it's 6 times 5 minus 2x minus 1 squared dx. Again, I can put out the 6 square, so it becomes 36 pi. And move out the 6 square, 0, 1, 5 minus 2x minus 2 dx, so 36 pi. And we have 5 minus 2x to the power of minus 1, so it's negative, divided by negative 1, yeah? And then divided by negative 2. 0, 1, so equals to 36 pi. I put the half to the front, so it's 1 over 2. And then I have 1 over 5 minus 2x for 0 until 1. So this is 18 pi. And then I have 1 over 5 minus 2 minus 1 over 5 minus 0. So 18 pi, 1 over 3 minus 1 over 5. So equals to 18 pi, 5 minus 3 over 15. So it's 18 pi times 2 over 15 divided by 3 will be 5 and 6. So equals to 12 over 5 pi. And it is shown. Next, the diagram shows the curve and the point P and Q on the curve. The shaded region is bounded by the curve's y-axis and the line y equals to 2. Find the area of the shaded region. The shaded region here, we can use two methods. The first one, we can find the area of the rectangle minus with the area of the curve. That's the first method. So if we use that method, yeah, the first method, I can find it using the area of the rectangle. So the area of rectangle will be 2 times 1. And then minus integral between 0 until 1, yeah, of the y, x, 3x plus 1 dx. And this is equals to 2 minus, we integrate this, so 3x plus 1 to the power of half plus 1 is 3 over 2. So 2 over 3 and then divided by 3 again. Put 0 until 1. So it's 2 minus 2 over 9. So, and then I put 3 plus 1 to the power of 3 over 2 minus 0 plus 1 to the power of 3 over 2. So 2 minus 2 over 9, 4 is equals to 8, minus 1, so 2 minus 14 over 9. So it's 4 over 9. That's the first method. The second method, is you can find the area using the y-axis. So this is the second method. The area is integral of x dy. For the boundaries, it will be from 1 until 2. So it's 1 until 2. So integral 1 until 2. The x here, so y squared will be 3x plus 1. So that means x here will be y squared minus 1 over 3. So I can put it x equals to y squared plus 1 over 3 dy. Or minus, yeah? Minus 1 over 3. Okay, I can put 1 over 3 out. And then I can just integrate this 1 over 3y cubed minus y 1, 2. And I have 1 over 3. 1 over 3, 2 cubed minus 1 cubed minus 2 minus 1. So it's 1 over 3. 1 over 3, 7 over 3 minus 1. So it's 4 over 3, so 4 over 9. The same result. You can choose one of them. II. Find the volume obtained when the shaded region is rotated to 360 degrees about the x-axis. So we rotate this, so the volume will be pi y squared dx from 0 until 1. So the same in here, we will deduct the equation here. So it is the rectangle minus the curve. So this formula is for the curve, the volume between the curve and the x-axis. So the volume now will be the rectangle. The rectangle rotated through the x-axis will be a cylinder. This will be a cylinder with radius of 2 and height of 1. So this is cylinder pi r squared height minus pi 0, 1 y squared dx. So that means in here, pi 2 squared times height minus pi integral 0, 1 y is 3x plus 1 square root but square dx. So I can remove the square root. So it's 4 pi minus pi integral 0, 1 3x plus 1 dx. So 4 pi minus pi 3 over 2x squared plus x 0, 1. So 4 pi minus pi times 3 over 2, 1 squared minus 0 squared plus 1 minus 0. 4 pi minus pi times 3 over 2 plus 1 equals to 4 pi minus 5 over 2 pi. So it's 3 over 2 pi. That's it. The third one, tangent are drawn to the curve at point P and Q. Find the acute angle between the two tangents. So P and Q, we draw the tangent there, the tangents here, and of course the tangents here. And we are looking for the acute angle between the two tangents. So we can find the gradient of the tangent first. So for the at P, so we find the equation of the tangent, y equals to 3x plus 1 to the power of half. So dy dx will be equals to 1 over 2, 3x plus 1 to the power of negative 1 over 2 times 3. So this is equals to 3 over 2, 3x plus 1 to the power of negative 1 over 2. When x equals to 0 at P, the gradient m equals to 3 over 2. When x equals to 1, the gradient is equals to 3 over 2 times 4 to the power of half. So equals to 3 over 4. Now, we know that the gradient is rise over run. So we can find the angle using the tangent. So at P, the angle theta will be tangent inverse of the gradient 3 over 2. And at Q, the theta will be tangent inverse of 3 over 4. So to find the acute angle between the two tangents, we just deduct the angle of theta 1 and the angle of theta 2. So the acute angle theta will be equals to the angle theta 1 is here at P, so tangent inverse 3 over 2 minus theta 2 here, tangent inverse 3 over 4. So this is equals to, this is in the degree, so make sure that your calculator will be in the degree mode. So it's tangent inverse 3 over 2 minus tangent inverse 3 over 4 equals to 19.4 degree. Next, the diagram shows part of the curve which minimum point at M and y equals to 5 intersect at A and B. Find the coordinates of A, B, and M. So A and B are the intersection points, so we can equalize the equation. So y equals to y, x plus 4 over x equals to 5. So x squared plus 4 equals to 5x. X squared minus 5x plus 4 equals to 0. So x minus 4, x minus 1. X equals to 4, x equals to 1. So A will be 1, 5. B will be 4, 5. And M is the minimum point. So we have to derive the equation. Y equals to x plus 4 over x. So dy dx equals to 1 plus minus 4 over x squared. And because this is minimum point, so stationary point, so equals to 0. So that means 4 over x squared will be equals to 1. So 4 equals to x squared. So x will be plus minus 2. But since m here is a positive number, so x equals to 2. And then y equals to, we just put it into the formula, 2 plus 4 over 2 equals to 4. So m will be 2, 4. I find the volume obtained when the shaded region rotated 360 about the x-axis. So again, this is a straight line. So we will have the cylinder with radius of 5. And the height of, this is 1, this is 4, so this is 3. So the volume will be pi r square height minus integral pi y square dx. So pi times 5 square times 3 minus pi integral from 1 until 4 y square. So this is x plus 4 over x squared x. So we have to expand. So this will be 75 pi minus pi integral 1 4 x squared minus plus 8 plus 16 over x squared dx. So equals to 75 pi minus pi, so 1 over 3x cubed plus 8x minus 16x minus 1 from 1 until 4. So 75 pi minus pi 1 over 3, 4 cubed minus 1 cubed, plus 8, 4 minus 1, minus 16, 1 over 4, minus 1 over 1. 75 pi minus pi, this is 63 over 3. Yeah. 63 over 3 is 21, yeah? So I just change it 21 plus 24 minus 1 over 4 minus 1 is negative 3 over 4. So it's plus 12. So this is equals to 21 plus 24 plus 12. 75 minus, so it is 18 pi.